So the first question is find the thousandth digit of a number n if n is a number made up of the numbers written from 1 to 1000 in that order. So the question is saying if I write down 1, then 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on up to 99, then 100, 101 up to 999 and so on. If I continue like this, then if I count the digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the unit digit of 11 is the 13th digit. If I keep on continuing like this, which will be the thousandth digit of the number n? So for this, how many one digit numbers do we have? One digit numbers we have is 9, right? 1 to 9. And what will be the number of digits that we are going to count if we count these 9 digits? These are 9 digits overall. How many 2-digit numbers are we going to have here? So 2-digit numbers, it starts from 10 and it stops at 99. So 10 to 99, how many numbers are there? So there we are going to have 92-digit numbers. How many digits will it account for? So it's going to account for, so this was 1 into 9, this is going to be 2 into 90. So this is 9 digits and this is 180 digits. How many 3-digit numbers do we have? So it starts from 100, it stops at 999. So we have 900 such 3-digit numbers. So the number of digits that are there in those 900 3-digit numbers is 3 into 900, which is 2700. So if we add all the digits, so it will be more than 1000, right? So that means that we have to stop somewhere in the 3-digit number part, because 9 plus 180 is 189. So we have only reached almost 200 digits. We have to reach 1000. So if I cover all the 3-digit numbers, I will cross 3000. I will almost reach 3000, right? So we can say that out of 1000 digits, if we remove the first 9 digits of 1-digit numbers, and then if I remove 180 digits, which are from 92-digit numbers, so I will be left with 811. So 811 digits, I have to go further from 1 of 100. That digit 1 that is there in 100, from there I have to count 811 digits. Now, if you look at the pattern here, every number is a 3-digit number. So if we look at 811 digits, how many 3-digit numbers are we going to have? So we'll divide it by 3, which is going to be 270 as the quotient and 1 as the remainder, right? So the first 3-digit number is 100. The second 3-digit number is 101. The third 3-digit number is 102. If I keep on going like this, then 270th 3-digit number from the left hand side starting with 100 will be how much? So this is what we need to figure out. So there is going to be a pattern, because if you look at the position 1, 2, 3 and 270, they are increasing, and so does 100, 101, 102 and so on. So what happens is, if I see first and 100, there is always an increase of 99. 2 plus 99 is 101, 3 plus 99 is 102. So if you follow this pattern, 270 plus 99 is going to be 369. So the 270th 3-digit number is 369, and this one remaining would mean that 271st 3-digit number is going to be 370. Out of this 370, that remainder 1 means the next 3-digit number ka first digit is going to be what? Had the remainder be 2, then we would have been looking at what would be the second digit from the left hand side of 370, which is going to be 7, of course. Okay, so that remainder tells us next number ka which digit from the left hand side is what we have to look for. Since we are looking at remainder 1 is the first digit of 370, so the answer is going to be 3. Right? Yeah. Hi Rita. Good afternoon. Okay. Next question. If a number 14A37B0 is divided by 88, then find the list value of A plus B. Since 88 would mean 8 and 11, so this number is going to be divisible by 11 if 7B0 is in the table of 8. So this is not cross, this is actually multiple of 8. Okay. So in the table of 8 in 700s, we can have 710, nay, 720, yes, 730, 740, 750, 760, 770, 780, 790, nay. It's only one number that we can have. So this tells us that the B has to be the digit 2. Now 11 ke liye, for 11, the difference of the sum of alternate digits, that's 0 plus 7 plus A plus 1, which is 8 plus A, minus 4 plus 3 plus B, B is 2, right? So 4 plus 3, 7, 7 plus 2, 9. This is going to be 0 or 11 or 22 and so on. In other words, any number which is in the table of 11. Now 8 plus A minus 9 is equal to 0 will give us A is equal to 1. 8 plus A minus 9 is equal to 11 will give us A as a 2-digit number, which is going to be 12, right? So the only possibility for A to exist is going to be 1. So B is 2, A is 1, so the sum is going to be 3. Sum पूछ रहे हैं ना हमसे, so we will add these two. Okay, next one. How do we go about such questions where we have got factorials and we are asked how many factors it is going to have or how many prime factors? Vice versa, if the prime factors are given, how would we know what factorial that is? So if n factorial has exactly 15 prime factors, how many values of such n are there? Since we are talking about 15 prime factors, that would mean 2, 3, 5, 7, 11, 13, ऐसे नहीं लिखते, 5 5 करके लिखते, it will be easy to count. So 5, then 13, 17, 19, 23, 29, that's another 5. Then we will have 31, 37, 41, 43 and 47. So this is another 5. So total 15 prime factors we have. So we can say that n factorial is going to have 2, 3, 5, 7 into 11 and so on up to 47. All these numbers are getting multiplied, right? So we can look at this and say minimum value of n is going to be 47. In 48 also, right? In 48 factorial also, 47 tak to 47 will exist. 48 factorial is made up of 2's and 3's, so it will add up to number of 2's and 3's. It will not bring in a new prime number. Similarly, 49 factorial, 49 is a number that is made up of only 7, so 7 will exist. 50 is made up of 2's and 5, so 50 में कुछ नया prime number नहीं आता है. 51 is made up of 3 and 17, so they both already exist, so new prime number will not be added. For 52, we have got 13 and 4, so both are already going to exist. 13 and 4 is made up of 2's. 53 is going to be a new prime number, right? So if I talk about 53 factorial, it will include 53 also, which will take the count of total number of prime factors of 53 factorial to be 16 prime factors. So 53 is not accepted. In other words, since it is talking about 15 prime numbers, so 15th prime number tak जाएंगे and 16th prime number के पहले तक, whatever numbers exist, every number's factorial will have exactly 15 prime numbers, 15 prime factors. So we have a total of, if we count, 6 such n's that are possible. right? Next, out of the first 1000 natural numbers, how many numbers have an even number of factors? Well, you should know, I mean, this is going to be straightforward only if you know that odd number of factors, it exists for perfect squares and vice versa, and even number of factors will obviously exist for non-perfect squares. So when the question is asking us how many numbers have got even number of factors, they are indirectly asking us how many non-perfect squares exist up to 1000. So 1000 तक कितने perfect squares हैं? So, you know, instead of writing down all the non-perfect squares and adding them, that will be a humongous task. That will be very difficult. So, एक काम करते हैं. We are saying that there are 1000 numbers from 1 to 1000. From there, if I subtract all the perfect numbers, perfect squares, not perfect numbers, perfect squares, I'll get all those numbers which are not perfect squares. So how many perfect squares exist up to 1000? So for that, we will have to do square root of 1000. Square root of 1000 is 31 point something, because 32 square is 1024, 31 square is 961. So 31 point something, which means 1 square, 2 square, 3 square up to 31 square. These all values exist from 1 to 1000. So if I remove them, I will get all those numbers which are not perfect squares. So these are perfect squares, these are total. If I subtract, I will get non-perfect square, because every number is either a perfect square or a not perfect square, right? We do not have a third scenario कि उसको भी consider करना, or there is nothing, you know, there is no number which is a perfect square as well as a non-perfect square which is, you know, included in both or something like that. ऐसा कुछ नहीं है. Okay, next. How many natural numbers are factors of 240 but not a factor of 420? So, let's call this number as A and let's call this as number as B. So, the number of factors, okay, number of factors के लिए I'm going to write NOF, number of factors. Number of factors of 240 is going to be 2 to the power 4. पहले तो 240 को prime factorize कर लेते हैं. So the number A is 240, which can be written as 2 to the power 4 into 3 into 5, power being 1 each. And the number B, which is 420, which is going to be 2 square into 3 into 5 into 7. Power set being 1. So number of factors of 240 is going to be powers plus 1 ka product for all the prime numbers in its prime factorization, which is 5 into 2 into 2, which is 20. Similarly, number of factors of 420 is going to be power plus 1 into next power plus 1 into next power plus 1, sare powers ka product with after adding 1. So this is 8 into 3, 24. Now, which all numbers or which all factors will be there in both, right? Suppose if I look at the number 2, 2 is a factor of 240, 2 is a factor of 420 also. So we shouldn't take 2. Similarly, 3 is a factor of 240, 3 is a factor of 420, 5, 10 and so on. So अगर आप ध्यान दोगे तो ये numbers 2, 1, 3, 5, 10 and so on, these are nothing but common factors. दोनों में exist करता है तो common है. So can I say if I remove all the common factors between them, then the remaining will give us the factors which are unique to that number. So we need to now calculate number of factors of HCF of 240, because HCF itself includes common factors. And since the highest common factor is a common factor, then its factors will also be a common factor. उसके अलावा there cannot be any other common factor, because we do not have any other term which includes common factor. यही एक term होता है. So HCF of 240 and for 420 is going to be number of factors of 2 to the power 2 into 3 to the power 1 into 5 to the power 1. I hope you are aware of how to figure out the HCF. HCF may you write down only the common prime numbers and the lowest powers. So 2 is common in both, the lowest power is 2. 3 is common in both, lowest power is 1. 5 is common in both, lowest power is 1. So this is going to give us power plus 1 into next power plus 1 into next power plus 1. So this is 3 into 4, sorry, 12. So 240 के 20 factors में से 12 factors are same as that of 420. Similarly, 420 के 24 factors होते हैं. Out of those 24 factors, 12 factors are there which exist in 240 as well. Since we are asked to find out the factors of 240 and not 420, as in it is unique to 240 but not 420, तो हम लोग सीधे 20 minus 12 कर लेंगे and this will give us 8, right? So 20 would mean number of factors of 240 minus 12 would mean number of factors of their HCF, and we will get the unique factors. Right? Okay. Next, how many natural numbers when converted to base 5 are 4-digit numbers? Well, the smallest number which when converted to base 5, so base 5 में the smallest 4-digit number is 1000. This is the least value, and the largest number in base 5, a 4-digit number in base 5 is 4444. This is the largest value, right? So count कर लेते हैं. If we convert this into its decimal equivalent, this is going to be 1 into 5 cube. This is 125. And if we calculate this in base 10, this is going to be 125 plus 25 plus 5 plus 1 into 4. Right? So 125 plus 25. इसका expansion कर रहा हूँ मैं. Right? 4444 in base 5 is 4 into 5 cube plus 4 into 5 square plus 4 into 5 to the power 1 plus 4 into 5 to the power 0. So I can take out 4 common, and 5 cube is 125, 5 square is 25, 5 is 5, and 5 to the power 0 is 1. So this is going to be 156. So this is 4 into 156, which is going to be 624. So all the numbers from 125 to 624, they are, when converted to base 5, result in a 4-digit number. So 125 to 624, these are total of 500 numbers, right? Okay, next, find the smallest number which has exactly 18 factors. देखो भाई, अगर total we are going to have 18 factors. These 18 factors could have been calculated by taking 17 plus 1, and since we are talking about smallest number, तो 2 to the power 17 से आएगा ये. Reverse engineering of calculating number of factors of a number. The other way is 18 can be written as 9 into 2, which can be written as 8 plus 1 into 1 plus 1. This will come from 2 to the power 8 into 3 to the power 1 से. आप उल्टा देख लो. If the number is 2 to the power 8 into 3 to the power 1, the number of factors will be power plus 1 into next power plus 1. That is 9 into 2, 18. The other way could be 18 can be written as 6 into 3. 6 can be broken down as 5 plus 1 and 3 as 2 plus 1. This may have been from 2 to the power 5 into 3 square. Next way to represent 18 is 3 into 3 into 2, right? So 3 into 3 into 2. So this may have come from 2 to the power 2 into 3 square into 5 to the power 1. Right? Now, out of all of these, this is a huge number. This is 2 to the power 8, which is 256 into 3, which is going to be in 750s. This is 32 into 9, which is going to be approximately 300. and this is going to be 9 into 2, 18 into 10, which is going to be 180. So 180. The other way to solve this was, since we are asked find the smallest number, तो smallest number से शुरू करते, we could have prime factorized 180, which is going to be 2 square into 3 to the power 2 into 5 to the power 1, and then calculated the number of factors of this. Instead of doing the reverse engineering, this would have resulted in 3 into 3 into 2, which was 18. So 180 हो जाता answer तब भी. So you could use options, and if it was a theta question, this is how you will have to proceed. Okay. Next. So whenever I am solving a question, and if you are watching it later, if you're not watching it live, what you need to do is you are looking, the moment I say, okay, next question, then you should pause the video, try to solve it yourself, and then play it again. Okay. So resume the video and see how the solution unfolds and what are the approaches, how to solve it if you were not able to solve it. So 24 coconut trees, 51 palm apple? No, palm apple to nahi hona chahiye. 51, let's say apple trees, and 57 areca trees. So the way the type of trees we have, so obviously apple will not be there, it should be palm. Common sense laga rahe. They have to be planted in rows such that each row contains the same number of trees of one variety only. Minimum number of rows in which the trees may be planted is. So if you look at the numbers 24, 51 and 57. So 24, 51 and 57 ka aap le lo HCF, which is going to be 3. 3 is the largest number which will divide all the 3 numbers. Okay. अब ये 3 का मतलब है कि if I look at 24 coconut trees and if I plant 3 coconut trees in one, if I plant 3 coconut trees in the next, and if I plant 3 coconut trees, so I will have a total of 8 rows, right? Of course, this looks like column, so uska tension mat lo. I am doing this because I have enough space horizontally rather than vertically. Next, if I look at 51 palm trees and if I it's palm, so P. So if I look at 51 palm trees, 51 is 3 into 17. So 3 palm trees, another 3 palm trees, and if this continues, another 3 palm trees. This will give us a total of 17 rows, right? 3 into 17, 51. 57 would mean 3 into 19. So since we have areca trees, so I will have 3 areca trees. In the next row, I will have 3 areca trees, and eventually I will have 3 areca trees. So this will result in 19 rows. So the question asked is the minimum number of rows in which these trees should be planted is 8 plus 17 plus 19. 8 plus 17 is 25, 25 plus 20 is 45, minus 1 is 44. So 44 ho jayega. Right? So visually this is happening with another set of questions. Take care.